Hi fourth graders, welcome to another day of math. Today we are going to be talking about two specific kinds of measurement, metric measurement I should say, and that is the metric measurement of mass and the metric measurement of volume. And just to remind you what exactly each of those things are, is mass is the amount of matter in an object, and we record that amount of mass in either kilograms or grams. There are other ways to measure because it's the metric system. You can have the decigrams and the centigrams and all of that. But for us right now in fourth grade, we're going to focus only on these two, kilograms and grams. Okay, we're also going to talk about volume, and volume is the measurement of space that something takes up. So we measure those in liters or in milliliters. And again, you can also have centiliters and kiloliters, but in fourth grade are only going to focus on these two. I want to just show you real quickly that the abbreviation for kilograms is a kg, lowercase k, lowercase g. The abbreviation for grams is a lowercase g. The abbreviation for liters is an L, and it can be tricky because it kind of looks like a 1, right? So just make sure that you're using an L. And milliliters is an M and an L together. Notice none of those are capitalized, they're all lowercase. So when you're recording in your units, make sure that you record them like this and in lowercase. All right, so let's start off with a couple of questions just to make sure that we're in the right space to be thinking about this today. So I want you to think about the words kilograms and grams, and I want you to think, which one do you think is actually heavier? Do you think a kilogram or a gram is heavier? Well, hopefully you said kilogram, okay? Because remember, kilo, we learned, means 1,000, and it's in front of the word gram, so there's 1,000 grams in a kilogram. Notice I'm saying kilogram and kilogram. You can really say it either way, but I don't have one preference, so I say them both ways. A kilogram is 1,000 grams, and grams are our unit. So remember that we have 1,000 grams in 1 kilogram. So we are going to multiply by 1,000 today. Okay, and likewise, I wanted to ask you, which is greater, a liter or a milliliter? Hopefully you are thinking liter, because again, that's the unit, and milli is another prefix that we put in front of the words to tell us how big it is, and milli also means 1,000. Now, you might be thinking, well, how can kilo and milli both mean 1,000? Well, it depends. It is on how you put the word together, or think about the word. So kilo means 1,000, so there's 1,000 grams in 1 kilogram, and milliliters means that there are 1,000 milliliters in 1 liter. So if you remember yesterday, the chart that I made, that kind of looked like a place value chart, kilo is on one end and milli is on the other. And so they are both 1,000 working their way to the middle to be the unit. So they're kind of the biggest and the smallest is the kilo and the milli. Let's give this a whirl. So let's say we have some, this is our T-chart, and we have liters on this side and milliliters on that side. So to convert between the two, we need to multiply by, remember, 1,000. So if I have 1 liter of water, let's say, and I want to find out how many milliliters that is, I simply need to take my number of liters and multiply it by 1,000. So 1 times 1,000, simple, is 1,000. So 1 liter is equal to 1,000 milliliters. Okay? Now, let's say I have 2,000 milliliters. How many liters would that be? So again, whatever I put over here, I'm going to multiply by 1,000 and it will equal 2,000. So what do you suppose that would be? Remember, we're going to be blurting at the TV or the computer today and not worrying about not blurting because we're not in class. But remember, when we get back to class, we're not blurting, right? Promise me that. But hopefully you're blurting to me that the answer here is 2. So 2 liters equals 2,000 milliliters. Okay, next one we have 4 liters. How many milliliters would that be? So again, we are going to simply multiply it by 1,000. So we have 4 times 1,000. Everybody tell me what that should be. That should be 4,000 milliliters, right? So what if I have 7,000 milliliters? So again, whatever number I'm writing under liters has to be multiplied by 1,000 and it will equal 7,000. Did you say 7? Because that is correct. 7 is the number we're looking for. Notice that relationship across the chart, the table here. We have a 1 and a 1,000, a 2 and a 2,000, a 4 and a 4,000, 7 and 7,000. So looking at the next one, which is 10, what would this number be? We're going to multiply by 1,000, so 10 times 1,000 is 10,000. We're going to be a lot of milliliters in here, don't we? Okay. All right, I want to give you a second to think about this one. 23,000 milliliters. How many liters would that be? Looking at our pattern, knowing that we're multiplying by 1,000, what number should be here? Are you thinking 23? Because if so, you are correct. 23 liters is equal to 23,000 milliliters. All right, next one, 145 liters. Getting to be a little bit bigger numbers here. But again, if we're following this pattern, it looks like we're just taking whatever number we have over here in orange, putting it here, and then putting 3 zeros behind it because we're multiplying by 1,000. So this would be 145,000 milliliters. Pretty easy pattern to follow there, right? So I did put a decimal, one with a decimal in here just to test you, to see if you remember from yesterday what we talked about. So remember, each time we multiply by 10, that decimal point is moving one place to the right. So it's in between the 2 and the 7, it's between the 1s and the tenths, but we need to move it 3 times because we're multiplying by 1,000. So we'll move it once, and it would be here, making the number 27. We would move it again, so we put a 0 here, we'd make the number 270, and we're going to move it one more time to make the number 2,700. Now notice, we're still in the thousands, right? We still have a number these are all thousands, which makes sense, but we do have a number in the hundreds place, which we didn't before. And the reason for that is because we had a number in the tenths place to start with. And when we move the decimal point 3 places, the 7 stays next to the 2, but it just gets moved into a different place, which is the hundreds place. Okay? All right, moving on to mass, talking about kilograms and grams. So remember, kilo means 1,000, so there are 1,000 grams in 1 kilogram. So again, we are going to simply be multiplying by 1,000. So let's start with 1. If I have 1 kilogram, how many grams is that? Well, we do 1 times 1,000, which gives us the good old number of 1,000. So 1 kilogram, 1,000 grams equal. Okay, how about 3,000 grams? How many kilograms would 3,000 grams be? Something times 1,000 equals 3,000. Are you thinking 3? If you are, you would be correct. 3 times 1,000 is 3,000. Moving on to the next one. 5 kilograms is equivalent to how many grams? So we do 5 times 1,000, which would be, everybody say it with me, 5,000. Okay, so 5 kilograms equals 5,000 grams. All right, working one backwards. If I have 9,000 grams, how many kilograms would that be? Again, looking at my pattern, I have a 1 here, a 1 here, a 3 here, a 3 here, a 5 here, a 5 here. So what do you suppose is going to go here? Looking at that pattern, it should be a 9. So we have 9 kilograms is 9,000 grams. Okay, we're getting to be into some bigger numbers, but the pattern doesn't change. We continue no matter what size the number. So we have 12 here, timesing it by, or multiplying it by 1,000. So 12 times 1,000 gives me 12,000 grams. That's a lot of grams. That's why it's easier to say just 12 kilograms, because 12,000, we're getting into some big numbers that are hard to picture. All right, how about the next one? 27,000 grams. How many kilograms would that be? We have to think something times 1,000 would be 27,000, or 27,000 divided by 1,000. You would get the number 27, correct? Am I right? All right, we've got 2 more to go. If we have 361 kilograms, how many grams is that? It's a lot, right? And a lot is not the answer we're looking for, but it is true. It is a lot. Okay, so we do 361 times 1,000. So we take 361 and put our 3 zeros behind, and gives us this big number of 361,000. All right, and just like I've been doing, I threw in 1 decimal problem here to just test your skills. So if we are at 24 2/10, or 24.2, and we're multiplying it by 1,000, we are going to move the decimal point 3 places to the right. So moving it 1 place makes the number 242. Moving it 2 places makes 2,420. And moving it 1 more place makes it 24,200. Okay, now I want you to think about what we've been doing yesterday and today, taking these numbers and simply multiplying them by a 10 or 100 or 1,000. Isn't that a lot simpler than having to multiply by 12 sometimes and 3 sometimes and 16 sometimes? When we use customary measurement, we have all those different ones that we have to remember and multiply, and probably get out a pencil and paper and do some calculations. But man, with metric measurement, we're simply multiplying by 10, 100, 1,000. It's much simpler in my opinion. Wonder when the United States is going to catch on that we should use this. All right, let's do a couple of word problems just to see how we're doing on this idea. So Kenny buys 4 1-liter bottles of water. How many milliliters of water does Kenny buy? So he's buying 4 1-liter bottles, which means he has how many total liters altogether? 4, right? Because 1 bottle is 1 liter, 2 bottles is 2 liters, 3 bottles is 3 liters, and 4 bottles is 4 liters. So we have 4 liters, and we want to know how many milliliters that equals. So to get from liters to milliliters, there's a lot of L's and I's in that word. So to get from liters to milliliters, do you remember what we do? Remember, we multiply, and we multiply by 1,000. So we're going to take our number 4, and we're going to multiply it by 1,000, which would give us 4,000. So he has a total of 4,000 milliliters when he has those 4 liters of water. All right, and our last question for the day, let's take this one with Mrs. Ortega buying 3 2-kilogram bags of flour. How many grams of flour did she buy? So remember, she's buying, she bought 3 bags, and each of them are 2 kilograms. So we have one that's worth 2 kilograms here, one that's worth 2 kilograms here, and one that's worth 2 kilograms here. So how many total kilograms is that? 2, 4, and 6, right? So our problem is 6 kilograms, and we want to know how many grams that equals. So again, to get from kilograms to grams, we are going to multiply by That good old number that we've been multiplying by all day, 1,000, right? So 6 times 1,000 equals, oopsie, for some reason I just wrote 12. I was thinking the 2-pound bags, I think. So 6 kilograms times 1,000 equals 6,000 grams. That's a lot of flour. I wonder what I'm going to do with all that flour. Maybe I'm going to make bake a cake or make some cookies. Who knows? Make some bread. Okay, we're going to wrap up here for today. Remember that we have been dealing today with mass and volume. Mass is measured in both kilograms and grams, and to change from kilograms to grams, we multiply by 1,000. We also talked about volume, which is measured in liters and milliliters, and to get from liters to milliliters, we also multiply by 1,000. So, your job today is to go and practice this, both with grams and liters. Remember, both ways, multiplying by 1,000. Please remember to ask your teacher if you have any questions, and be sure to complete your work on time. And don't forget, if you've been watching and you have been finding those secret letters today, see if you can unscramble those letters and see what word they spell. If you can figure it out, message your teacher and see what they say. See if you're right. Keep with it, 4th graders. We'll talk to you soon.